equation now. So this is y minus y1 equals the slope times x minus x1. I only have 1, so I have to plug it in and get the y1. So when x is 1, this is e to the third power and times natural log of 4. Ugly, but that's what it is. So this is 1 and this is e to the third natural log 4. Now I have to determine this piece. Like you just told me a few minutes ago, y prime. But careful, this is a product. First function prime is e to 3x multiplied by 3 times the second function, as is, and plus e to 3x times the second function prime, which is 1 over 4x, times the inner function prime, which is 4. So I'll simplify, and there is nothing else I can do here. So I just rearrange it a little bit. 3 e to 3x natural log 4x plus e to 3x divided by x. This slope is y prime evaluated when x is 1. So y prime when x is 1 is, so this is exactly what I just had, but with a 3 in front. So 3 e to the third natural log 4, 3 e to the third natural log 4, plus, when I plug in 1, I have plus e to the third. Couldn't find anything uglier than this. Okay, so y minus e to the third natural log 4 equals that. So 3 e to the third natural log 4 plus e to the third multiplied by x minus 1. My goodness. So I have to distribute x in here, negative 1 in here, and move this to the other side. I really didn't, in a long time, didn't see anything this ugly. Okay, so 3 e to the third natural log 4 plus e to the third times x minus 3 e to the third natural log 4 minus e to the third, but plus e to the third natural log 4. Y equals, I cannot do anything here other than if you want, you can factor e to the third. And here I have minus 2 e to the third natural log 4 minus e to the third. My goodness. So this is the slope, and this is the y-intercept. And no, my answer is no, no. You're not going to have something like this. I try not to test endurance, ever. Good. Next topic, next question, anything you want.
On that same page, can we look at number 85?
Yes. So they want us to differentiate this. Okay, perfect. That one is okay. No, I'm not saying not to show these problems in class. Oh, absolutely, yes. So we have an idea of what's happening here, but okay, so you said 85, so we have g of x equals natural log x raised to the 4th power. When we differentiate, always remember we start from the outer. So g prime of x is 4 whatever to the third times the inner function prime. So I have natural log x. The inner function prime is 1 over x. And this is it. You can rearrange it if you want. But there is nothing else. It's the chain rule. Make sure you don't put plus or minus here. Careful. So a function raised to a power 4 times the function raised to 4 minus 1 times the inner function prime. Good. So I'm not cutting the class short or anything. I just wanted to say that please, Thursday, have a list of questions so we use the time efficiently. So I'm assuming that you're going to review all tests with solutions and the homework, the assignments, etc., and you will have more questions. That's my hope, okay? Good. Next question. What are we working on next?
Professor,
Yes, I'm ready.
it's just a question. Is it going to be open notebook test?
Yes.
Okay.
I don't know. Was it Liam or Nick?
Is me.
Okay.
I had a problem on my lab math a while ago that kind of stumped me, and it was
Yes. Let's take a
deceptively
look.
simple. It was just the indefinite integral of natural log x
So,
dx.
like natural log x dx,
Mhm.
it shouldn't
What
be in
was?
there. It shouldn't be in there. Let me tell you why. Because this is integration by parts. So it's x prime times natural log x dx. Because x prime is 1. So then this will be x natural log x minus the integral from x times 1 over x dx. Okay? So this is x natural log x minus the integral of 1, which is x plus a constant c. This is integration by parts. This is a topic that we did not cover in this class. I'm not sure where, maybe by mistake it was selected or something. No, we don't know how to do this in this class.
Gotcha.
So now you can always check by differentiation. The indefinite integral you can always check, right? So when you differentiate this, you will get that. Guaranteed. Good. Next topic.
Actually, I just have a quick question. If we could look at it and you could tell us if something's similar, like if we should even review it. Page 548, number 24. Is it a chapter that we went over? I know that with 6 we kind of picked it apart, but I wasn't sure because I didn't think we had seen anything similar to it.
Let's take a look. 24. Find relative max and min. We can. So remember, it's the D test. So we have to find fx, fxx, fxy, fy, fyy, fyx, and determine the and look at the D test. We can look at it. Let me copy it. Yeah, I'm curious now. Well, normally when it's say synthesis, then I'm assuming they consider it as a little bit more difficult. It's a very good point. Since you're asking, why not? So I will rearrange it a little bit as xy plus 2x to negative 1 plus 4y to negative 1 to make my life easier to differentiate. Let's see where we're getting. And I'm assuming that you're looking at other questions, right? So fx, when I differentiate with respect to x, y is fixed. So this is y. This is fixed as 0. So this will be negative 2x to negative 2. Okay, and now fxx will be 4x to negative 3. And fxy will be 1. Okay, let's see fy. I have x minus 4y to negative 2. Fyy will be 8y to negative 3. And fyx has to be 1. Okay. Now let's see what I get when I create the systems. Because as you know, the next step Some of you stopped and just determined. So this is a very good point you're making here. Some of you on the homework and also on the test determined this, created the system of y minus 2 over x squared equals 0 and x minus 4 over y squared equals 0, determined the point whatever, comma, whatever, and said it's max. No. No, please don't do that. Remember, after you determine the point or point of intersection, or if you want the points that verify both equations, then you have to conduct the d-test for each point. If you don't conduct the d-test, you cannot say anything. This is, where does this come from, right? Remember when we had a few minutes ago, let me say this. This is a similar test like here. I know that this is a max or a min, right? When the function, the derivative changes sign this way, it's a min. If it changes sign this way, it's a max. So this is similar, but this time is for two variables, or if you want a function with two variables, right? So you can conclude before you study the sign. Same thing here. So instead of this, we have the d-test for functions of two variables. So do not just say, I got the point, it's a max, or I got the point, it's a min. No. So please remember that. Okay. So what am I doing? So I'm trying to solve these equations. So I have y equals 2 over x squared. And from here, I have x equals 4 over y squared. I'm just going to replace it in here. So I have y equals 2 over. So the difficult part is probably determine the intersection. Okay, so I have to square it. So I have 16 over y to the 4th. Right, so x squared is 16 over y to the 4th. I have to flip. So then y equals 2y to the 4th over 16. I simplify. And then I cross multiply. So y to the 4th equals 8y. I have y to the 3rd minus 8 equals 0. Although the degree is 4, there are only two real solutions. These are non-real. So y equals 0 and y equals 2. Okay, so the points are 0 and 2. And let's see x now. Oh, that's not possible because I cannot plug in 0 here. So there is only one solution. And the other one for, when y is 2, 4 over 4 is 1. So there is only one point. So now we have to determine the d for this point, which is fxx at 1, 2 times fyy at 1, 2 minus fxy at 1, 2, but squared. Okay? So where is my fxx? So I only plug in 1, so that's 4. Fyy, I only plug in 2, so that's 1. And this is 1. So this is 4 minus 1, which is positive. And because fxx is positive, it means that 1, 2 is a minimum. Okay, because fxx equals 4. So these conditions, d is positive and f of x is positive, so this is a minimum. All this test tells us what the point is all about. Without the test, you cannot conclude anything. And this is the most important part. Thank you for picking that, Kirsten. Yeah.
I have a question. Why
Sure.
was fyy equal to 1?
So I don't have any x to plug in, so I only plug in 2.
Okay.
So this is the same with 8 over y to the 3rd. 2 to the 3rd is 8. 8 over 8.
Okay. Yeah. I
Better?
see it now. Thank you.
Better?
Yeah,
Yes.
thank you.
So no, again, I would say that this is a little bit of it's an interesting problem, but I wouldn't consider this a test or final exam problem. But it was a good practice for what we need. And careful, I did get a legitimate 0, but it cannot be legitimate for x. 4 divided by 0 is undefined. So that's why this point is out of question. It's not a point of intersection. Or a solution of the system. Good. Next topic.